Find the breaking depth dB in feet. In this problem, we are provided the unrefracted deep water wave height h0 prime, and we are also provided the period of the wave t. We are asked to find dB, which is the depth of water which causes the wave to break. The depth of water, d, equals the breaking depth, dB, when the actual height of the wave, HA, equals the breaking height of the wave, HB. Therefore, we can solve for the breaking depth by guessing values for the depth, d, and then checking whether or not the actual height equals the breaking height. For computational convenience sake, we'll divide these height terms by the length of the wave, L. When looking back at the possible solutions for the breaking depth, we'll begin by guessing a depth of 13 feet for our first iteration, because 2 possible answers are shallower and 2 possible answers are deeper. To enter the table of wave values, we next need to compute di over L naught. The letter I simply represents the iteration number, so we'll change this variable I to a 1 for our first iteration, and we'll plug in 13 feet into the numerator. L naught is computed as gt squared divided by 2 pi. After plugging in the known variables, L naught equals 865.013 feet. This value of L naught is a constant because variables g, t, and pi are all constant. This makes d1 over L naught equal to 0.01503. With the d over L naught value, we have an entry point into the tables, and we can linearly interpolate to calculate the values of d1 over L, which equals 0.04969. Next, we'll compute the wavelength, L, by dividing 13 feet by the value of 0.04969. And the wavelength for this first iteration equals 261.622 feet. Since the wavelength depends on the depth, we'll add a subscript 1 to signify the first iteration.